End behavior is one characteristic that we talk about when we talk about polynomial functions. I have a bunch of things up here that talks about end behavior. Here, let's read them. End behavior of a polynomial function f of x. F of x is just the name of our polynomial function. Don't get tripped up by him. Is defined as the actions the graph exhibits. Man, look at all these like big English words. As the x approaches infinity or negative infinity. As it approaches negative infinity or positive infinity. What the heck is it trying to say right here? Now, if you don't speak math, then you don't know that that is simply just saying the left side or the right side of the graph. But don't worry, we have other bullet points that say that. Here we go. We are looking to see if the function goes in an upward direction forever, or the function goes in a downward direction forever on each side. What do you mean each side? The right side and the left side. Where x approaches negative infinity, or where x approaches positive infinity. And finally, this last bullet kind of sums it all up. This is the most understandable bullet. Generally, we state it as the right side is up or down, and the left side is up or down. Okay, so we're just talking about the left side and the right side of the graph. Is it going up or is it going down? See, check this guy out. I have a really simple function here. I have a second degree polynomial function, which you guys know affectionately as the quadratic function, right? You guys know the quadratic function. Can you guys write down right now what the end behavior is of this graph and what the end behavior is of this graph? Now, check your neighbors and see if they're correct. I walked around and I listened, and it sounds like a lot of you guys are getting it. Some of you guys for this one are saying, oh, down, down. Okay, well, it's more appropriate to say left is down. And I'm still simplifying it. And then right is down. See, it's important that you make sure you talk about both the left and the right-hand side. But like I said before, there's a math way to write this. So let me show you guys the math way to write this. The math way to write this is as x is going to negative infinity. That would be left. As x is going to positive infinity. That would be right. You see, this is the x-axis. Here is positive infinity. That's x. Here is negative infinity. So negative infinity is the left side of the graph. Positive infinity is the right side of the graph. So let's call this the y function. I mean, you could also call it f of x or g of x, but let's just call it y. This y function is approaching what as we go left? It's approaching down. So down would be negative infinity. And then on the right side, we have the same direction. It is approaching negative infinity. I'm not going to... Oh, yeah, I will. Another one. So this one, left is up. Right is up. So now we got the right left, which is negative infinity, and we have the right. I'll answer your question in a second. Hold on. Is positive infinity, and then we're going to say y is going to positive infinity and y is going to positive infinity because they're both going up. So they're both positive infinity. All right, so that's done. Let's go over to this guy. Let's talk about zeros. Zeros are x-intercepts. In fact, right here, this third point, right here, generally we'll state it as zeros of f of x, or you can say zeros of g of x, or you can say zeros of y, zeros of the polynomial function. But these could also be called, now you got to underline these guys, they could also be called roots, solutions, or x-intercepts. Zeros can be called roots, solutions, or x-intercepts. That has 3 different names. So if you run into a different name, know that it's just talking about the zeros. Zeros is the shortest word, except for roots. Roots is kind of the same distance, or amount of numbers. A zero of a polynomial function, f of x, so f of x is our polynomial function that we're talking about, is defined as the solution to the equation of this. Well, that's kind of confusing. Here, let me write f of x let's see, standard form. X squared plus 2x plus 1 equals 0. The solution to this equation would be any x value that would make it equal 0. Now, I wrote a really simple one. And you could probably guess some numbers and see if it works. But ain't nobody got time for it. Well, we do have time for it. Well, I don't have time for it. I'm not going to wait for you guys to guess. Now, this is written in standard form. there's another form that you can write it in that would make it easier to find the zeros. You guys ready for this form? You guys know how to factor? You guys remember how to factor? Okay, well, I will factor this for you right now. If you factor this, it's going to be x plus 1 times x plus 1. It's the same function. Same function as what the other one, except this is factored form and the other one is standard form. They're the same though. But this one makes it easier to find the zeros. Now when you multiply two numbers, only one of those numbers has to be 0 for it to equal 0. Right? I mean, that's just common sense, right? I think. So what value of x would make this first factor, this one right here, what would make that one equal 0? A negative 1. So you can say that one of the solutions is negative 1. And then you look at the other factor to see if there's another number that would work. And you go, wait a second, that's the same factor. So in this case, it only has one solution. I don't know if you remember this. This is from Algebra 1. You can have one solution, two solutions, or no solutions. But right now, we're pretty much going to focus on 1 and 2. 1 and 2 solutions. Let's see. Let's read the rest. We are looking to see where the function touches or passes through the x-axis. See down here? We're going to go to this guy in a second. Right there, you find a 0. And right there, you find a 0. Here, let me highlight those for you guys so you see what's going on. This is a 0. This is a 0. Okay? You just have to know what those x values are, and those are your zeros. Okay? And look, I already said this. It is easier to find the zeros when it's in factored form. So let's move this page up a little bit. I need you guys to find the zeros and then write me an equation that would give me those zeros. Go. Okay, here we go. It's like the Michael Jordan song. I always think about, I don't know if it's Michael Jordan. Okay, so we got negative 1 and 2. Those are your zeros. Negative 1 and 2. They're the x-intercepts. So, let's think about this, my students. For my equation, I'm going to write y equals. And I'm going to write two factors because I have two zeros right there. I could have more factors, but we're not going to get into that. Let's just think about this. What would this factor have to say if 1, 0 is negative 1? X plus 1, right? Because it would have to make it 0, right? That negative 1 would have to make this factor equal 0. If I plug negative 1 into that, will it be 0? Yes, it will. So what would this one be? X minus 2. Oh, so you guys are catching on, yeah? Yeah? X plus 1, X minus 2. Let's remember that guy. I want to use him later. The next one, let's see, we got a point right here. That's negative 1. And another 0 right here. That's 3. And so we have negative 1 and 3. This would be y equals, this would be x plus 1, and this would be x minus 3. Okay, now, there's a big mistake that I'm making. My factors are beautiful. They are correct. They will give me those zeros, but this equation should look different than this equation because this graph looks significantly different than this graph. Very nice, Norma. You got it. There's a negative on one of these. Which one is negative? This one. So I need to put a fat negative sign right in the beginning of it.